Okay, another quick video to help you out with the review for your quiz. I know some students were struggling with some of this. If you take a look on here, um, I'm going to publish my solutions, but you can kind of see them on here, and you can pause the video and look at all of this if you'd rather do it that way. Of course, you have to be able to do this on your own, so you need to practice this without looking at the answer key. You are going to have to, answer these questions. We have a min, it's going to happen at 0, 0, and the min value is 0. Okay, because you look here and you see that right here, the lowest value is 0. So the min is 0 at the point 0, 0. Okay, over here, we were looking for a max. So you're looking for the largest number here. Okay, 8/3 is 2 point something. So this is bigger than that. So your max is 3, and it happens at the 0.10. So make sure that you are doing that. The other thing I wanted to mention about this is one of these, and I'm pretty sure it's going to happen on your quiz, one of these is going to have a point that does not intersect in the crosshairs of a grid. So what I mean by that is, and let me enlarge this a bit, when I look at something like right here, up, down, that's what we call the crosshairs of the grid, okay? This ordered pair right here is not in the crosshairs of a grid. This one is. So this ordered pair has integer coordinates. This ordered pair has integer coordinates. This ordered pair, 0, 0, has integer coordinates. But this one over here, maybe I can change the color of that. Maybe I can't change the color of that. But this point right here does not have integer coordinates. So what you need to do in that case then, I'm going to delete all this stuff. In that case is to get the coordinates for this point, you have to write and solve a system. Okay. Maybe I can use this highlighter. You're going to write and solve a system. I'm not using that highlighter because it's not highlighting it the way I want to. All right. So you're going to take the equation or the related equation of this line and the equation or the related equation of this line. It has to be those two lines because those are the two lines that intersect at that point. Do you see it? So you have to use the equation of this line that I highlighted in blue and this one that I highlighted in green. You have to write a system, okay? And that's what this work is over here, right? These are the equations of the two lines that intersect to form that point. And so you can use elimination, you can use substitution, doesn't really matter, but you do have to find the x and the y where those two lines intersect, because that is going to be the coordinates of that feasible region for that boundary point right there. Okay, so keep that in mind. Is that going to be that way on your test? Yes, it is going to be that way on your test. Okay, you will have a problem where you have to write and solve a system. Okay, if you look at this example over here, well, this intersects in the crosshairs of a grid. So does this one. So does this one. So does this one. So I don't have to write and solve a system to get the coordinates or the vertices of my feasible region for that problem. But for this problem, I do, because you see the intersection point there is in the middle of a box. It's not on the crosshairs of the grid, right? So if you still have questions on that, see Mrs. Newton. She's our backup. She's helping us out. All right. As far as the systems, I was looking at your homeworks that you had submitted for me. And I will say that I did not have enough students showing me this. Okay, you need to stay organized. If you're using substitution, you have to say what variable you're eliminating and what two equations you're using to accomplish that. You must eliminate the same variable because I want my resulting equation, okay, this one here. I want this resulting equation and this resulting equation to both have an x and a y so that I can then put them together in its own system, which I did right here. This equation is this one, and this equation is this one, okay? I'm going to put those together so that we can solve and eliminate either x or y to get my value of x, to get my value of y, so I can back substitute. Now, once you find out what x or y is here, in this case we found out what y was, it's cut off probably on the copier when I photocopied this. Excuse me. You're going to take this value of y and back substitute into one of these that I have here highlighted in green, okay? So you're going to back substitute into one of those. I chose to go here with the y value, and I calculated the x value. And then once you have your x and y, then you're going to go back up into one of the original equations from the original system. And it looks like I chose to use the middle one right here. Okay, I chose to use this one right here. That's this right here. Okay, that's how you're going to find your z. And then you have to give your answer in terms of an ordered triple. It has to be in order. There's got to be x first, then y, then z. Okay. I believe number 4 here, I used the substitution method. So you're going to take one of the equations. I chose this one because it only had 2 variables, okay, an x and a z. And I solved it for z because the coefficient was 1. So I said z equals negative 5x plus 7. So then I took this quantity and I substituted it into this equation for z and the other one in for z. You have to be careful because you do have a subtraction sign here. And so you're going to have to distribute that negative to both the 5x and the 7. The negative 5x and the 7. You see right here. I'm showing you right here. Okay. So this equation, sorry, is this one. And then this equation right here, I don't know why that keeps doing that. This equation is this one. Okay. So I have to take what z equals and substitute into both of the other 2 equations. Okay. And that's going to give me, again, just like this one over here, it's going to give me 2 equations with both x and y. See, because I replaced the z with either just x, just so happened in this problem it was that way, but this could be an x and a y, but you're still going to get equations here in this step. Right here, you're going to get equation 1 and equation 2 in terms of both x and y, and you're going to put them together. And right over here, you're going to use an elimination. You either eliminate x or y. It doesn't really matter. It makes more sense to me to get rid of the y's. They're already a pair of opposites. Okay, solve for x. Once you get x, substitute back into one of these to get the y. Once you get the x and the y, substitute back into one of the equations in the original system and get the z. And you can tell at the end if you are correct or you're not correct because 1, 1, 2 should make this equation true, and this one. If this is a true solution, when you substitute the 1 in for x, the 1 in for y, the 2 in for z, and do the computation, they all should work with this set of 3 numbers. Okay, again, if you have any other questions, please let me know. Reach out to me or reach out to Mrs. Newton. Alrighty, good luck on your test.